Okay, in this video, I'm going to talk about matrices and how they relate to linear systems. So let me start off by defining a matrix. A matrix is a rectangular array of numbers. Okay, so here are three examples of matrices. The first case here, since we have two rows and two columns, this is an example of a 2 by 2 matrix. Here we have 1, 2, 3, 4 rows and one column, so that's a 4 by 1 matrix. And in this case we have 2 rows, 4 columns, so that's a 2 by 4 matrix. So in general, matrices are described by rows, the number of rows, by the number of columns. Okay, these numbers here are called the entries of the matrix. Okay, let me talk about operations on matrices. Okay, if matrices are the same size, you can add them. Okay, you can also subtract them if they're the same size. So for example, here I have a matrix 1, 2, 5, 3. And I have another matrix. Okay, so this is a 2 by 2 matrix. So I have to, if I want to add it, I need to add another 2 by 2 matrix. So I'll say -1, 3, 2, 9. The way I add matrices is by adding corresponding entries. So I have 1 plus -1, which is 0. 2 plus 3 is 5. 5 plus 2 is 7. And 3 plus 9 is 12. The way I subtract matrices is I subtract corresponding numbers. So if I have 1, 2, 9, which is a 3 by 1 matrix since I have 3 rows and 1 column, minus 2, 12, -3, I get 1 minus 2 is -1, 2 minus 12 is -10, 9 minus a -3 is 12. Okay, let me give you a couple to try. Okay, press pause while you work on these two examples. So you should have gotten this here for the first case. And you should have gotten the matrix 1, -9, -2, 2 for the second answer. Okay, now let me talk about matrix multiplication. Okay, so let's multiply these two matrices together. To get the first entry here, I'm going to take the first row of the first matrix dotted with the first column of the second matrix. So I take 2 times 1, which is 2, plus 1 times -1, which is -1. 2 plus -1 is 1, and so that entry is a 1. To get the next entry in my first row, I'm going to take the first row again of the first one, but now the second column of the second one. So I have 2 times 9, which is 18, plus 1 times 2, which is 2, and that gives me 20. I have no more columns left in the second matrix, so now I move on to the second row. To get this entry here, I'm going to use the second column of the second row of the first matrix and the first column of the second matrix. So I have -3 times 1, which is -3, plus 4 times -1, which is -1, and that gives me -7. Finally, I'm going to take the second row of the first matrix and now the second column of the second matrix. So I have -3 times 9, which is negative 27, plus 4 times 2, which is 8, and that gives me negative 19. Okay, so the product of this matrix times this matrix is the matrix 1, 20, negative 7, negative 19. Okay, so just to recap, to get the entries of the first row of the product, I used the first row of the first matrix and then each column of the second matrix. To get the second row, I used the second row of the first matrix and then each column of the second matrix. Okay, let me give you one to try. Okay, press pause while you work on this problem. Okay, to get the first entry, we're using the first row and the first column. So we have 2 times negative 2, which is negative 4, plus 1 times 4, which is 4. So we have negative 4 plus 4, and that's equal to 0. Now we have another column, so we keep using the first row. So now we have 2 times negative 3, which is negative 6, plus 1 times 1, which is 1, so that leaves us negative 5. We have no more columns, so now we move on to the second row. We have 1 times negative 2, which is negative 2, plus 3 times 4, which is 12. Negative 2 plus 12 is 10. Finally, for this entry, okay, the second column in the second row, I use the second row in the second column. So 1 times negative 3 is negative 3, plus 3 times 1, which is 3. So negative 3 plus 3 is 0. Okay, so what you notice here is that the number of columns of the first matrix has to equal the number of rows in the second matrix. Okay, let's see why this is true. So suppose we have the matrix 1, 2, 3, 9. Okay, that has 2 columns. Now suppose we have 3 rows in our next matrix. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so then to multiply these, we take the dot product of the first row and the first column. So that's 1 times 1 plus 3 times 4, but we don't have anything to go with this 7. Okay, we would need another column here in the first matrix. So that's why, in order for multiplication to be defined, the number of columns in the first matrix must be equal to the number of rows in the second matrix. Okay, here's one more example for you to try. Press pause while you work on it. Okay, so the first entry here, we use the first row and this only column. So we have 2 times 2 is 4, plus 1 times 1, which is 1, plus 1 times 3, which is 3. So we have 7 plus 1, which is 8. Since we don't have any more columns, we're only going to have one column here in this matrix. So now to get to the second entry, we take the second row of the first, dotted with this column. So we have 1 times 2, which is 2, plus 0 times 1, which is 0, plus negative 1 times 3, which is negative 3. So that's equal to negative 1. And now finally we move on to the third row and this column. So we have 3 times 2, which is 6, plus 0 times 1, which is 0, plus 2 times 3, which is 6, so we have 12. So this product here leaves us with this 3 by 1 matrix. In general, the size of the product is going to be the number of rows of the first by the number of columns of the second.